Okay, sir. Let us get started. So, as promised in the last class, first of all, I'll tell you the reason why we didn't have a class yesterday. There was a Jira class yesterday, and a lot of students were overloaded with too much of classes over this weekend, so I had to cancel Windows and PowerShell class yesterday. Right? So today we'll be focusing on list comprehensions and anonymous functions, and along with that we will try to use some of the problems which we have solved much earlier in our classes. So first of all, okay, let me try to look at a problem, and then by looking at that problem, let us try to solve this. Okay, I'll not write too much of notes, but let's try to solve project Euler problem 1. Okay, some of the people call it as project Euler, right? Yeah. So right, so let me go to project Euler and then archives. Okay, so basically this is a problem. Okay, the problem is if you list all the natural numbers below 10 which are multiples of 3 or 5, then we get all of them, and if you calculate the sum of all of them, it is 23. Then what is the sum of all of them over here? So let me take this, and where is my notes? Let me refer here. Okay, so let me solve let's solve it using traditional mechanism, right? So Python file, let me add a Python module. Okay, I'll call it as Euler 1. Okay, define traditional underscore solution. Okay, right. So in this method, right, let me minimize this. In this method, let's look at traditional solution for project Euler problem 1. Okay, so this is the problem 1's description. Now if you look out for this problem 1, it is trying to tell that if you list all the natural numbers below 10, okay, which are multiples of this, right? So I'll be starting, all the natural numbers will start from 1, and which are multiples of 3 or 5. So I'll be starting with for index in range of 1 comma, let me give it as 10. Okay, right. So let me try to put okay, max underscore number equals to 10. Max underscore number. Okay, now I will be trying to write that if index is, okay, divisible by 3 is equals to 0, or index is divisible by 5 is equals to 0. Okay, so if the number is divisible by 3 or 5, then I will try to put something like sum or result is equals to 0. You would be trying to tell that I would add that sum plus equals to index, and then at the end you will basically try to tell return sum. Okay, right. And we have learnt, okay, how to basically set up PyTest. To test this method, I'll be using PyTest. I'll not be manually executing it. So let me install PyTest. Pip install PyTest. Sorry, PyTest. Okay, right. And then let me try to basically create a new Python file, which is test underscore Euler1.py. Okay, let it be okay. Okay, so basically I'll be calling define test underscore traditional solution. Okay, so in this test case we will test the traditional solution for project Euler or Euler, whatever it is, project Euler 1. Fine. Now let me try to tell that I want to import Euler 1. Okay, fine. What is the problem with this? There is no module named Euler 1. Rename reference. Right. Fine. Let us see. What is the error? We'll try to resolve it. Let it fail. Right, sir. Now over here, what I'll try to do is Euler 1 dot. Okay, I have traditional solution. Now let us see what it tries to tell. Import problems to dot Euler. Yeah, this is a map package, right? Good. Traditional solution, and then let me pass 10, and then I'll try to tell that assert this should be equivalent to 23, and let me add a configuration, add a template. I want to add a PyTest. Okay, and then my path will be project Euler problems 2. Right, apply, do this, and then let me debug this solution. Let me put a breakpoint over here and let me debug this. Okay, now I want to step into traditional solution, so I'll go over here. Okay, I'll put a breakpoint over here, and then I'll try to tell that okay, resume program. Now if you basically look into it, I'm using the shortcut keys, right? Sum is 0, right? Now if you basically look, sum is 3, 8, 14, 23. So now let me resume the program. Okay, so if you look into the console, the test should have passed, or if you want to run the test, just run the test. It tries to tell that your test case is successful. Okay, our solution is passing. But this is a traditional approach. Now let us see if there is other way of doing it. Okay, there are some of the PEP 8 guidelines. So let me try to tell result, refactor, and reformat the file. Good. Yeah, this is a traditional solution, and let us quickly run the test. Right, everything is passing. Now let me use def list comprehension solution. Okay, So if I have to use a list comprehension, how will I basically look into this? All right. So let us assume that for every element, okay, which is divisible by which is part of list, okay, I would want to create a list of elements from 1 to 100. Okay, so using a range function, right? So how can I create a range to create a list? So I'll try to tell that. Okay, my list, my underscore numbers is equals to list of range of 1 to max underscore number. Okay, so my underscore numbers underscore list. Okay, good. Now I want to use a list comprehension. So how can I use a list comprehension? Let us see. So what is a list comprehension first of all, right? So the list comprehensions are basically a easier way of making lists. Okay, right? So for example, I'll try to give a list comprehension example. Okay, I'll not use it. I'll take the REPL. So let me go over here, Python. Okay, I can try to write that I want to create squares of numbers is equals to, okay, I'll be writing index star index, okay, for index in range of 10. Okay, now if you try to see what is the squares of numbers which I have, okay, squares of numbers, if you see I have all the numbers over here. This is the most easier way to create the list. Okay, now let me apply the same logic over here. Okay, now I'll try to tell that this is my numbers list. I can easily create a list, but not only that, I can write some conditions also. I can write some expressions also. Okay, I can write some expressions also, right? So let me go over here, syntax of list comprehension. Okay, it would be something like, okay, new underscore list is equals to, here you will be writing expression for member in iterable. Okay, any iteration. Okay, this is one way of doing it. New underscore list is equals to expression for member in iterable, which is a list or any iterable for that matter. Okay, and here you can write if conditional. If your condition satisfies, then only add the items to the list. Okay, so basically I have put it in square brackets just to denote that they are optional. Just to denote that they are optional. Okay, right. So now let me try to write all of this in a very simple function saying that, okay, multiples is equals to, okay, index, okay, for index in range of, okay, max underscore number. Okay, range of max underscore number. Okay, right. And then here I'll try to write if index percentage 3 is equals to 0, or index percentage 5 equals to 0. Now let me try to reformat this file. Let me blindly copy this expression, okay, and go into REPL and then create max underscore number is equals to 10, okay, and then let me write it. Let us see what will be the value of multiples. Square bracket. Okay, now if you try sum of multiples, did you got 23? Alright, so now I am just using that expression over here. So I'll tell that 1 to max number, and then return sum of multiples. Okay, let me go over here and then define test underscore list comprehension. Okay, so what is that we are trying to do in this solution, or in this test case? In this test, we assert for Euler problem 1 using list comprehensions. Right. So now I'll try to tell assert Euler 1 dot list comprehension function of 10 should be equivalent to 23. Right, now let me run the test cases. So both of them have passed. Both of them have passed. Okay, isn't it simple, sir, to write a list comprehension? Right, okay, and you might see also people doing this. Okay, so writing this statement, okay, or you might even see people doing this. Okay, let me write that in comments so that you can basically apply whatever that makes sense to you. Right, so what you might end up saying is your if condition might not be at the end, but rather it might be index. Okay, so let me comment this one out. Let me uncomment this. Okay, let me run the test case. Okay, we have messed up something, so there is some failure. If what is that I messed up? Right, if index is equals to 3. Okay, right. If you have here we have to write the else part. Okay, if you write the condition over here, so let me write else 0. Okay, now let me try to run this condition, so you get the same thing. All right, so the choice is yours. I rather use the first conditional statement. Okay, the choice is absolutely yours. Right, this is the second approach. Okay, conditions can be placed in the front as well. Right, sir. Okay, you can basically do this comprehensions not only for list, you can do it for dictionaries also. But there, rather than using a square, you will be using a curly brace. Right, fine, sir. before we get into this, I am interested in one more function type, which is called as a lambda function. Lambda function. All right. So let me try to tell you what this lambda function is. Let me try to write something like, okay, what should I write? Let me try to use the same square. Okay, I want to call the square, so I'll be writing square equals to lambda. Okay, and then x colon x star x. Now when I call square of 5, it returns 25. Okay, now what is lambda over here? Okay, let us try to understand that stuff. Okay, in Python, okay, first let me commit this change set, sir, so that we'll not have any issues with respect to this. So copy, reveal in Explorer. Where is that? Show in Explorer. Right. So let me go with project Euler. CD git status. Okay. Git add dot git commit -m added Euler 1 solution, right? And then let me use git push. Right, sir. So let me give this change sets result. Okay, so let me go over here. Added Euler 1 solution. I think it is looking good. Okay, so refer here for list comprehension based solution for project Euler problem 1. Okay, right, sir. Now what is a lambda function? Okay, anonymous functions. In Python, functions which do not have a name. In Python, anonymous function, okay, is a function that is defined without name. Without name. Okay, so for normal functions we use def keyword. Okay, and for anonymous functions, okay, we use the lambda keyword. Okay, right. So syntax, okay, syntax of the lambda expression is lambda arguments, and then what is the expression? What is the expression? Right. So very simple. Okay, right. So now let me solve the same project Euler problem, okay, with a lambda statement. With a lambda statement in that. Okay, so def, okay, lambda underscore solution max underscore number equals to 10. Okay, so in this approach we will be using list comprehensions, right? Okay, over here in this approach we will be using lambda functions, right sir? Now okay, lambda functions can be very easily defined, here. What is the lambda function which we want? Okay, so we want a lambda function, okay, def, okay, sorry, is underscore multiple is equals to lambda of, okay, x, okay, colon, what is that we need to do? What is that we need to do, sir? If basically it is divisible of 3 or 5, then we should be basically writing a lambda function, right? So now how to write this expression, right? It is pretty much straightforward. You have to return true or false over here. You have to return true or false over here. So now, but whole of this lambda expressions are basically based out of something called as lambda calculus. Okay, now I don't want to get into all of that, but let me try to make it simple for you. All right, so what is it I need to basically return? Lambda x. Okay, so you give me a number, okay, and then I'll try to tell you whether it is divisible by 3 or not. Okay, right. So x percentage 3 equals to 0, or x percentage 5 equals to 0. Now this is fine. Let me reformat the file. Right, sir. Now let me basically copy this expression in REPL, and then let me try to write is underscore, sorry, multiple of, okay, let me try to check for 1. Okay, it tries to tell, okay, multiple, it tries to tell false. 3 true, 5 true, 6 true, 7 it should give me false, and 9 it should give me true. Okay, right? So now basically I can use this lambda function, okay, which I have written inside my code in a very simple way, right? So let us try to apply that expression. Let me go over here, and then I will try to tell that, okay, for index in range of, okay, or in range of 1 comma max underscore number. Okay, so if is multiple of index, then result equals to 0. You will be trying to tell that result plus equals to index, and then let me try to write return result. Okay, fine. Now fine, sir, what is the other stuff which it is trying to tell? I can write directly lambda there, but it's okay. Is there any do not assign lambda expression, use a def. Okay, he's asking me to write a function instead of lambda expression because of the readability factors. That's okay, we can ignore this error. Let us try to see if this works out. Okay, test underscore, okay, lambda, okay, and Euler underscore lambda solution, okay, using lambda expression. Right. Now let me run the test cases. I am not interested in debugging them anymore. So all of my 3 test cases have passed. So now if I change the max number equals to 1000, I'll try to get, if you want to check the value, you will basically get the value of it. Right? Good, sir. Now what we will try to do is, let us go to project Euler problem 2. So let me go to problem 2. Okay. So each new term in the Fibonacci is generated by adding the stuff over here, and he is trying to tell that what is the sum of even valued Fibonacci series, right? So first I need to generate a Fibonacci series. Okay, so this we have done loads of times, and then basically generating a Fibonacci, okay, is something which we have done lot of times, right? So while we were learning the basic languages, okay, we have tried to understand how to do that. Now if I want to do it in a different fashion, or if I want to basically do it in a Pythonic kind of a way, so one is you can use recursions, right? You can define a function, and then you would basically call that function multiple times, right? So I'm not interested in Fibonacci series basically, but okay, if you want to write a Python program for that, there are you have to go with a traditional loop. Okay, so with the traditional loop, add the items to the list, and once you have items to the list, then we can write a very simple list comprehension. Okay, so let me try to basically go over here, and then problem 2. You have to write a list which looks like this. Okay, now here you are adding the items to the result, okay, and then you calculate them. We have done this already, right? So this, rather than this problem, let me go over with 3, because in this problem I'll be trying to fit the solution. Okay, the prime factors of 1, 3, 5, 9 are wonderful, right? So we have to calculate prime factors. Okay, forget about the problem. So let me go with problem 3. I'll go to problems 2, and then let me add a new Python file. Okay, Euler 3.py. okay, add the item to the get. Right, so prime factors, define prime underscore factors of number or value, whatever you call it. Okay, value equals to 13195. In this method, we will try to find prime factors. Okay, right, sir. So how do I basically find whether the number is factor or not? Okay, so is underscore factor. Okay, I'm going to write a lambda expression for this. Okay, I'm going to write a lambda expression which speaks about how do I basically find a factor. Is factor of, okay, x comma y. colon, okay, x percentage y is equals to 0, and then is factor is equals to lambda. Okay, now let me reformat this file. Okay, right. So what I'll try to tell is, okay, for index in range of 2 comma value divided by 2, okay, if is underscore factor of, okay, value comma index, okay. If you don't want to do this, you can directly write this expression. But generally you would see people doing that. Okay, now yeah, it is a factor, and then the next thing which you need to find out is whether if it is a prime or not. Okay, so how do you know if it is prime or not? Okay, how can I tell whether the number is prime or not? To tell whether the number is prime or not, I have to divide this. I have to find out this number should not be divisible by any number from apart from 1n itself, right? So let me quickly go ahead and then write def is underscore prime of value, okay, for index in range of 2 comma value by 2, okay, is prime number is equals to true. Okay, so if let me write it over here. Okay, so if is factor of, okay, value comma index, okay, then is prime underscore number is equals to false, break this loop and return is prime underscore number. Okay, now if is factor and is underscore prime, okay, so then you will basically consider this to be a prime factors, right? So those are the prime factors, right? So then you will be adding that items to the list. Then you will be adding those items to the list. Now let me write a list comprehension for this. Okay, so prime factors found is equals to array of, okay, for, okay, array of index, right? So how did we write a list comprehension earlier? So if you see over here, for index in range of, okay, I'm going to do the same thing for index in range of 2 comma value divided by 2, okay, if is factor and this, okay, done, and then return sum of prime factors found. This is something which we call as Pythonic code. You're writing the code, okay, right, value //2, right, sir. You are writing the code in a very simplistic manner. Okay, here yeah, I am messed up over here, value //2, right. Okay, so if you look out for this, the prime factors function looks very simple. Okay, so these are the kinds of expressions which people would end up using, right? So if I have defined a library of is function, right, if you let me show you the traditional program of problem 3. This is a traditional one. Okay, here also we have basically written one is divisible by function and then is prime function. We have written all of that. But when it comes to the Pythonic way of basically doing the things, I have written all of them in a very simple list comprehension. I have used the list comprehension and I have used lambda also, right? So lambda functions, there are best practices. I have not spoken about best practices in today's class, but right, let us try to test this. So let me go ahead and then add a test case. Okay, new Python file, test underscore Euler 3, and then okay, from problems to import Euler 3, right, and then define test underscore prime factors. Okay, now let me go to the problem statement, right? So oh, there is no sum of, you have to just return result of, right, return multiples. Okay, right, so Euler 3 dot prime factors of, okay, 13195, okay, assert if it is equals to, okay, 5, what are the values, 5, 7, 13 and 29. Okay, let me reformat the file so that I'll follow all the standard guidelines. Okay, test underscore prime underscore factors, okay, and then let me run the test case. Okay, so list comprehensions have failed. Okay, right, so something is failing over here, which is strange. Test underscore list underscore comprehensions. Okay, for some time. Okay, I want to skip this unit test. Okay, using the markers which Python or Pytest basically gives us. Let us see. Okay, so @ Pytest dot mark dot skip. Okay, reason is equals to, I need to import this, import Pytest, right, reason equals to, we'll check later, right. Okay, right, now let me run the test cases. I should see only one test failure. Alright, so test underscore prime underscore factors, it is trying to tell that you are getting 0 as a result. Okay, let us focus on that. Man, I should. Okay. Oh, I think I have messed up over here. Where I have to return sum of multiples, I have replaced the stuff over here. Okay. Right. Now, let me try to basically look at this function. Okay. Prime factors. And now, let me go ahead and then tools, debug, toggle breakpoints, view breakpoints. I'm not interested in Euler 1. Right. Done. Now, let me try to debug this. Okay. Right. So, what are the prime factors that are found? There are no prime factors that are found. Okay. Why? Ranges, if E is factor, strange. I think I might be doing something wrong or silly over here. Right. 2 comma value divided by 2. Okay, since this is a very simple expression, let us try to write this. Okay. Okay, let me go over here, exit, and let us use the REPL. Much easier way. Okay, value equals to let me give 15. In 15 we have 3 and 5, both are prime numbers, right? And then let me write it. Okay, I have to define E is factor. X percentage Y is equals to 0. Okay, so now let me write E is underscore factor of 15 comma 3 true, 15 comma 4 false, 15 comma 5. This is working correctly, right? Now let me execute prime factors. What is not found? Oh, I don't have E is prime. Right, so let me remove E is prime first of all. We'll narrow down the results. Now prime underscore factors underscore found. Okay, so there is something wrong with is underscore prime method. Okay, right, is underscore, yeah, value, right, this should be correct. I might be missing something. Is factor, if it is factor, I'm making it false. This seems to be right. Okay, we are getting factors found, but we are not getting prime factors found. Here basically, if you change value equals to 100, okay, and then if you try to basically print prime factors found, it will try to print all the factors. Okay, and now I want to find out whether that factor is prime or not. So is prime is not working for me. Let me try it out. So def is prime, right, is prime number is equals to true, yeah, and then copy, 1 2 3 4, yeah, if it is return false, return true. Right, good. Now let me try to add this function. Prime factors found equals to value. So there is something going wrong with this is prime, right? Let me debug is prime. That's it. So we know who is the culprit now, right? So good. Let me go and debug the solution. Okay, so right, I got to know what is the issue. That is not is prime of value, it is prime of index. Okay, now let us try to run it. So if you see, it is one small thing which we have messed up. Okay, now let me go and test your Euler 1 and let me try to remove this marker also, and let me try to run all the test cases. All should be passing. Yeah, right, sir. So if you see, this code is how it looks more Pythonic. Okay, so when you go into data sciences, when you go into NumPy and all of that stuff, you would see a lot of people using syntaxes like this, right? So, and it is not difficult, that's the whole point. So we are trying to understand that aspects of it. Okay, right. So in the next class, what I'll try to do is we will try to understand something called as Python data model. What is this Python data model? Okay, in Python everything is object. Okay, the function which we write also is an object. We will try to understand about that, and then we will get into inheritance. We will write some objects to the database, and then we will wind up our discussion of Python over this by this weekend. Right? So, but there is no ending here. We have basically tried to understand. I have tried to cover most of the aspects, right? But I'll try to cover whatever I can in the few days which are left. Okay, but this should give you enough knowledge on how to proceed. So let me give this, change it also to you. Git status, git add dot git commit -m added Euler 3 with comprehensions and lambda. Right, git push. Let me go to this Python batch 1. Right, here split is a better one. So let me go to the notes. Okay, so refer here for example with lambda and comprehensions. Right, okay, sir. So I'll stop it at that. We'll meet again tomorrow, where we'll try to understand what is the data model of Python, why in Python everything is a object, even function is an object. So we will look into how does that work out, and after that we will be basically getting into the other aspects of Python as what we have promised in the curriculum, and hope you guys are practicing, and that would be very much effective if you practice this stuff, right, sir? So this notes as usual will be present in python.direct website after this class in few moments, right, sir? Thank you. Thanks for your time.